Hello and welcome to another video in which we'll be looking at basic properties in geometry. And again, we're going to be continuing on with the topic of polygons. And we had discussed in the last video the sum of interior angles of a polygon concept. And today we are going to be talking about the second fundamental property, which is true for all polygons across the board, which is sum of exterior angles. The sum of exterior angles of a polygon, very simplistically put, any polygon, no matter how many sides, sum of exterior angles is always going to be equal to 360 degrees. Now, what do I mean by exterior angle? Exterior angle of any polygon is formed by the produced part of an existing side, or the produced part of a side with an existing side. So let's say I take the case of this pentagon, which is called ABCDE. If I produce a side CD to a point, let's say F, then DF is the produced part of CD, and the angle that it forms with an existing part is called an exterior angle. Now, people often think that the number of exterior angles of a polygon is equal to the number of sides. That if there's a pentagon, the number of exterior angles is 5. But the fact is that it's not 5, it's actually 10, because at every vertex, you can produce 2 sides. So I can produce CD to the point F to form the exterior angle FDE. I can also produce the side ED to the point, let's say, G. And I can get another exterior angle at the same vertex, which is angle GDC. These are vertically opposite angles, of course, and they're going to be equal to each other. But the fact still is that we can form twice the number of exterior angles as the number of vertices of any polygon. So a pentagon has got 10 exterior angles. A hexagon has got 12. A heptagon has got 14. An octagon has got 16, and so on and so forth. But when I say sum of exterior angles of a polygon is 360, I do not mean that for a pentagon, sum of all 10 exterior angles is 360. I mean sum of exterior angles formed by producing the sides in one direction will be equal to 360. So which means if I take all 10, then the sum will be equal to 720. But if I take every single side produced in one single direction, then I get 5. So the sum of those 5 angles will be equal to 360 degrees. Now, what do I mean by producing in one single direction? I mean that, let's say, I produce all the sides in the anti-clockwise direction. So this is how I'm going to be producing the sides. First, I'm producing CD, then DE, then EA, then AB, then BC. And basically, I'm going through the vertices in the anti-clockwise direction, and I'm producing the sides like this. And I'm getting 5 exterior angles. Similarly, if I produce all the sides in the clockwise direction, if I produce BA, AE, ED, DC, and CB, I will get 5 more. So sum of these 5 exterior angles formed by producing the sides in the anti-clockwise direction will be equal to 360. Sum of the 5 exterior angles formed by producing the sides in the clockwise direction will give me another 360 degrees. Now, why is this sum 360? There are multiple different ways to prove it. One is by a very visual proof. That if I take the side or the straight line CF, CF is completing one full rotation, and then it is forming all of the exterior angles during the course of its rotation. So one full rotation will be a total angle of 360. That's a very visual way of thinking about some of exterior angles. That will be equal to 360 degrees, and that can be used as a proof to prove that some of these 5 will be equal to 360 degrees. One very mathematical proof that I like is that I can take any interior angle. Let's say I take the interior angles, angle D, angle E, angle A, angle B, angle C. These 5 interior angles are each going to form a straight angle with an exterior angle. So every interior angle and its corresponding exterior angle is going to give me a total of 180 degrees. So which means if I add all 5 interior and all 5 exterior angles, I should get 180 degrees times the number of vertices. So in this case, in the case of the pentagon, I can say sum of all the interior angles plus sum of all the exterior angles will be equal to 180 into 5. Right? And we know, we have just derived in the last video, the formula for sum of interior angles of a polygon is n minus 2 into 180, which in this case will be 5 minus 2 into 180. Plus, I'm going to just call it SOE. Okay, sum of exterior angles, I'm going to represent that as SOE is equal to 180 into 5. So, which means that sum of exterior angles will be equal to 5 into 180 minus 3 into 180, which is 2 into 180, which is 360. And that is where the sum of exterior angles of a polygon comes from. You can prove this. You can use this proof for a polygon of any number of sides. And that is why sum of exterior angles of any polygon formed by producing the sides in one particular direction will be equal to 360 degrees. Thank you.